Kaminsky. I know that might be shocking to see me for most of you who haven't seen me for like 2 years. But when I am on campus, I'm usually over in Schultz with the Ed Young group, which is pretty much what I do these days. And one of our projects attracted interest from Zoie, who I had not met before. And so Zoie and I have been working together this semester to try to improve some of the work that we had been test driving with our N3 project. And I'm going to let Zoie tell you all about it.
Awesome.
It's my great pleasure to work with her. And I think that she really came up with some great stuff.
Hi, everyone. I'm Zoie. My project covers accessibility in STEM. And as Dr. Kaminsky relayed to you, we were collaborating with the EDION N3 project, which is NASA's Neurodiversity Network. And their main goal is to provide a pathway to NASA participation and STEM employment for neurodiverse learners with a focus on those on the autism spectrum. So that's what I will be covering today, including some concepts such as neurodiversity and accessibility. What are those things? The question, are we alone, which is my driving question for this project. Some concept maps that I made, the point of my project, and acknowledgements. Okay. So neurodiversity is the phenomenon that everyone has a different way of experiencing the world. I'd like to also mention that with science, especially with astronomy and physics, perception is everything. How you see phenomenon that's happening can sometimes actually shape what happens. So we'll see that in my later slides. Examples of neurodiversity include dyslexia, dysgraphia, ADHD, and autism, which I will be focusing mostly on. And there's no one way to be neurodivergent. So when making this project, I've been thinking to myself, how can I relay autism to a general audience? And I don't think that I can, because it's different within every single individual. If I were to put a diagram somewhere on here, that would be sort of narrow-minded, because then you would walk away. Come on.
I'm so sorry.
If I were to relay some sort of diagram on here, then most of you would walk away with a perception of autism that isn't actually what people experience all the time. And, okay. Okay, so this is actually what makes it difficult to diagnose, because it can look so different from every individual, which is why research must continue in order for us to get more examples and further, produce accessibility in classroom settings and professional settings. And what's significant about this is that white children are about 19 more likely than Black children, and 65% more likely than Hispanic children to be diagnosed with autism. So what that does is, if white men are the only one getting research, getting their needs met, then everyone else who's on the spectrum and everyone else who has a disability that isn't being addressed is, not as likely to do well. And what this does is it promotes white male dominance in scientific spaces, providing additional access to a group that is already in the majority. Okay. Neurodiverse students are underserved in academia, and some challenges include curriculum is not tailored to meet the needs of people who learn in different ways. It's very rigid. It's, one size fits all. And if a student needs extra resources, it's on them to figure out what they are and to then apply them in the classroom. And most of the time, it doesn't work out that way, because neurodivergence is not necessarily, it's not emphasized. And students who are neurodiverse struggle in settings with neurotypical rules and structures. So this is another way of saying what I had just said. Some consequences of this Neurodiverse students, namely those on the autism spectrum, face more challenges to succeed in their academics. And people on the spectrum are less likely to pursue higher education and have less access to careers. What's the significance, though? Why does it matter that autistic people are able to get the same opportunities as neurotypical people? It matters because we're scientists. We know that genetic diversity matters. We know that it's important to have different frames of reference. So if we're studying something only in one way, we're going to have limited results. We're not going to see the full picture. So what's accessibility? We're hearing this a lot nowadays. Accessibility is the quality of being easy to obtain or access something. This can be access to information or even a level playing field. In the classroom, it can look like a sensory-friendly environment. You might be wondering, why is Zoe trembling right now? Well, part of the reason, all these lights are on, and I happen to be autistic, and autistic people sometimes do better when it's just natural lighting in the room because we get sensory overload, and so noise reduction would also be beneficial in the classroom setting. In terms of the curriculum, which is more in line with what I've been working on, to-do lists for each class session could be very useful, as well as alternative tangible resources to keep material understandable, like activities, visual signage, etc. Noise-canceling headphones are one of my personal favorite tools to use. Many of you have seen me wearing headphones all the time. It can act as a stim for people who are on the autism spectrum. And what a stim is a self-soothing tactic. So fidget devices like this one here, you can move each of the sides in different ways. So it keeps it, with autism, sometimes there needs to be a physical release of energy in order to not get a buildup of stress and pressure. Instructional aids could also be useful, like trained teachers' aides to be present in the classroom. So in case a student needs to leave or take a second, then that will be appropriate, and someone will be there to help them if need be. And tools for non-speaking students, such as technology like the iPad or letterboards, and this is a letterboard here. It might not seem like all that thought out, but we have very clear responses to general questions like yes or no and please and thank you. And to a neurotypical group, this may seem completely irrelevant, but these resources can make a huge difference in how the student is able to process information and how they're able to communicate. So now we will get into my contributions. Okay, let's take a second to look at this, because I'm kind of on a roll here. So this is the Hubble Ultra Deep Field image. And what we're looking at is hundreds of thousands of galaxies and stars. Each of these galaxies, or most of these galaxies, have stars within them and star systems. Star systems like the solar system, which is where we're at right now. And so what does that tell you? The universe is infinite, right? Or unbounded and constantly expanding. So there are millions of locations for life to exist, but we still haven't found it. So my driving question to sustain interest is, are we alone in the universe? Which brings us to exoplanets, which are planets orbiting stars that aren't the sun. And they're a huge source of interest because some of them are Earth-like, which means that they might have liquid water or atmospheres that have similar properties as our atmosphere. Like that one kind of looks like Earth, and that one kind of looks like it has an atmosphere. This one does not look like it would harbor life. So we're not going to look for life on planets like that. So what is it that I was doing? I took some lectures from a sample classroom setting over the course of a couple weeks. There was a class in 2019 of neurodiverse high school students, and they were covering these 4 slides and giving feedback on what can be improved upon. So I took that feedback, and I also, used my own personal experience to go through each of these lectures and reframe them so that they were more accessible to a neurodiverse audience. And the way that I did that in particular was within each of these lectures, I made some tangible resources so that, for example, they would be given to the students prior to the class starting to keep them on track. So an example of this resource could be this is a summary of, the content that's going to be gone over in that class session. This one, you don't have to read all of it if you don't want to, but this is covering exoplanets and the data collecting section. And here I talk about, probability of exoplanets, like them being Earth-like, and some of the other stuff that I was saying before. So we'll just go ahead and move forward. So how can exoplanets help us answer the question of, are we alone in the universe? I gave you a hint, like we look for life on the Earth-like ones. So using that question of, are we alone, I decided to make this concept map that I'm very proud of it. So the main thing that I want to draw attention to is that we conceptualize the observable universe in 2 main ways, including physics and astronomy. So here, on the physics side, I have physical properties like the eyes in telescopes, the optics, and then astronomy, I have more observational stuff. And then we see how they intersect. We need telescopes to make observations, and so we need optics to make observations. And so they all come together like that. And if you look towards the bottom, so we have our sun right here. And then there are two categories of planets. We have rocky bodies, terrestrial planets, and gas giants, which is like Jupiter, Saturn, Uranus, and Neptune. But the rocky bodies, there's Earth. And Earth is Earth-like. And so there's life on Earth as a result of liquid water, atmosphere, it's in the habitable zone. So we look for properties like that when we're looking for Earth-like carbon-based life elsewhere. But we couldn't do this without humans. Humans conceptualize the universe based on perceiving it. So we wouldn't even be able to wonder if there's life elsewhere without looking up to the stars 100,000 years ago and wondering. It's, for me personally, it's very humbling to look at space and see myself as small and relatively insignificant in the grand scheme. All of us kind of are, but I just do with that what you may. But I wanted to draw particular attention to this because everything that we know, it's not something, the universe doesn't write laws and we uncover them. We create the laws to understand what's around us. And that's part of the reason why I wanted to study physics, because I wanted to understand what was happening around me on a fundamental level. I'm just pretty autistic, I guess. So the point is that not everyone learns at the same rate, in the same way, or with the same level of ease. And accommodating all types of students allows for intellectual diversity in STEM, And more importantly, it gives students equal learning opportunities. And these are my credits. And that's it. So, does anyone have any questions regarding anything?
I guess I'm supposed to help you with this part.
Yeah.
So when you did your research looking at the other life,
Mm-hmm.
there's thoughts that other life could even count as just single-celled organisms.
Mm-hmm.
What are your thoughts?
Like, do I think that life exists? I think that it's very likely because of how many places it could exist in the universe. Because there are so many Earth-like exoplanets that we haven't identified all of them, but because there are so many, I feel like the probability of finding at least microbial life is pretty probable. Yeah. Yeah.
So if you find some exoplanet and you're able to classify that it is Earth-like and has properties that could support life, are there any mechanisms which you could use to potentially prove or detect that there is life on that body?
Yeah, actually, so one method could be taking spectra of an atmosphere, because life could exist in the atmosphere, which is actually a project being done with Venus, I think. But that's an interesting point, because that brings in ethics. How ethical is it for us to go and probe and do research like that? That's a whole another mode of discussion. But to answer your question, mechanisms like taking spectra of atmospheres. Mm-hmm. Mm-hmm. Any other questions?
I have one, actually.
Sure.
So this is more on the education sort of side of your talk. So you seem to really enjoy making the concept map, and I've, in workshops and things, learned about doing concept maps with my students.
Mm-hmm.
I was just wondering if you've tried making them for your classes, while you've been, or if you would think that'd be helpful, like in E&M or even in 114. Do you think?
I think that would be helpful, because in learning about, how to operate using the pointing vector, for example, it could be like, okay, I know how to do this type of math, but I don't necessarily know where it applies. Mm-hmm. So I think making the concept map helps make those connections. Like, for example, temperature, I was talking about the habitable zone. The habitable zone is the Goldilocks zone in space, which is the distance from, it's a distance from the parent star. And if a planet is close enough, or if a body is close enough, and it might have liquid water on the surface. So all those details would be embedded in the lecture, but the driving home point is that temperature could be, caused by tidal heating or the habitable zone. So
yeah.
just
do you
making
think,
those
being
connections.
Provided one, or do you creating one yourself? Maybe this is the time.
Well, creating one,
beyond.
we've got time.
Yeah.
Creating one would actually be a lot of work for me to do.
Yeah, no, exactly. Yeah, that's what I was wondering.
So yeah, I feel like something like this could be given.
Mm-hmm.
Yeah, in the beginning of the class. Yeah. Yeah.
When it comes to accessibility in the classroom, since the needs are so individual,
Mm-hmm.
What are your thoughts on how do you handle that as the students turn over every semester and every year to meeting those individual needs?
I'm going to start by saying research, because we only have a white male model, as I like to call it. And so needs are only met based on that model. So it's like, oh, okay, if it's too bright, let's turn the lights off. But another autistic student might have a different set of needs. So I think that with research, we could find linkages between, okay, how does this group learn? How does that group learn? And then maybe go from there. But it starts with research. Mm-hmm. Awesome.
All right.
Thanks so much.
Thanks.